All right, let's take a look at 3.6, multiply and divide mixed numbers. Now, if you guys can multiply and divide fractions, we can simplify multiplying and dividing mixed numbers into 3 easy steps, which we'll see in the lesson. So the first thing we want to do here is learn how to change mixed numbers into improper fractions, which is going to come back to us, right? So I'm going to choose to use that cycle method. So I'm going to take the 16 and multiply it by 5 and add the 3, right? And we're going to keep that denominator in fifths. So 16 times 5, that's going to give us 80. And then adding the numerator 3 gives us 83. So this would be the improper fraction that represents that mixed number. Now you could check with a calculator, typing in 16 3/5 into it, and then just push enter. It'll change it into an improper fraction for you. Now this would be the first step in multiplying and dividing with mixed numbers. So if you can do this, and you may have to do it 2 numbers at times, but if you can do this, then again we're looking at 3 easy steps for multiplying and dividing mixed numbers. Now the third step would be changing improper fractions back into mixed numbers, and it only happens from time to time. Well, often, but not every time, okay? So you can see on this one, we took 29/7, just like we've done in the previous lessons. We took 29 and divided it by 7 with long division and changed it into a mixed number, with the remainder being the numerator of the fraction, the quotient being the whole number there, and we keep the denominator 7. But again, I would recommend using a calculator to do it, at least to check, okay? So again, operations with mixed numbers, right? And this is more if you're doing it by hand, because if you put it in the calculator, it goes pretty quick. But step 1, you're going to change the mixed number into an improper fraction. You do whatever operation you need. By the way, this works with addition and subtraction. And then step 3, just change that answer back into a mixed number. But do remember that if you divide anything by 0, does not exist. It's just undefined. So that's pretty quick and precise 3-step method for solving these. So let's put it in practice. Now the first thing I would do on this one is I would notice, hopefully, that the 2 numbers here that we're multiplying are negatives, which means I know that my answer is positive, so I don't need to worry about those anymore. So I'm going to use cycle method to change these into improper fractions, right? So this first one, 1 times 5 is 5. Then I add that numerator is 1. That'd be 6 in fifths. And this being multiplied by the negative 1 and 3/4. So 1 times 4 is 4. And then plus that numerator is a cycle, which is 3. 4 plus 3 is 7. So on this one I got 7/4. And now I'm multiplying. I can see a cross simplification with the 6 and 4. Both of those are divisible by 2. 6 divided by 2 is 3. 4 divided by 2 is 2. And I could look for any more values that could be simplified together, but I don't see any. That doesn't mean that there isn't. I just don't see any. So I got in the numerator 3 times 7, which is 21. And in the denominator, 5 times 2, which is 10. Now that would be pretty good, and it may not specify what it wants on the test, right? Like, do this, but it may not say it wants a mixed number. Usually if you start with mixed numbers, it wants a mixed number answer. So I am going to change this into a mixed number, all right? So 21/10. Now 21, that'd be 21 divided by 10. 10 goes into 21 2 times, at least evenly. 2 times 10 is 20. When I subtract, I get a remainder of 1. So this ends up being 2 whole pies, I guess, with a remainder of 1, and we were looking at this in tenths. So 2 and 1/10. Again, it's positive. And now I'll go to the calculator just to confirm, right? So -1, whoops, need a mixed number, -1, and 1/5. So 1/5, and this was being multiplied by another mixed number, -1 and 3/4. So 3/4. There we go, 21/10. Now we don't want that improper fraction, so I'm going to change it into a mixed number, second, that 10 to the power of n button, 2 1/10. That's what we got. So that confirms what we had, and we can feel pretty good that this one is correct. All right, now this one's division. Again, there shouldn't be a huge difference on these. The first thing I would do on this one, again, I'm just figuring out if the answer is positive or negative. These have different signs, so I know the answer is going to be a negative. And it'll be a mixed number, whatever it is. And I'll use the cycle method to change these into improper fractions. So I'll start with 4 times 3, which is 12. Then add that numerator 2 to get 14 thirds. Now right now I'm going to keep it as division. Not everyone shows this step. They move right into the multiplication, but I'm going to keep it as division and then move from there. So cycle method, 5 times 2, which is 10. And then add the 1, makes that 11 over 2. Now that I have both these as improper fractions, now I will change the operation to multiplication and reciprocate the fraction, 11 halves to 2 elevenths. So I got 14 thirds times 2 over 11. I don't see anything that can be cross-simplified. So again, I'm just straight multiplying the numerators. 14 times 2 is 28. And multiplication of the denominators, 3 times 11 is 33. So I have this. This is a proper fraction. Now, if your answer comes out as a proper fraction, just leave it. There's no need. You can't change it into a mixed number at this point. So just leave it as 28/33. But let's just double check, right? In the calculator. There we go. So this is really good to see this at the calculator, right? Like I put the full problem in the calculator. And yeah, I forgot to write the negative with the answer on this one. It's -28/33. I had it. I just forgot to put it in with the answer. And that works out a lot better. All right, so what about this one? 4 is just a whole number. We don't need to do much to change that into a fraction. It'd be 4 over 1. Yeah, the operation on this one is already multiplication, so I don't need to worry about that either because we want to multiply these. But I do need to change this -3 1/4 into an improper fraction. And again, I can look at my answer. I know it's negative because I got a negative times a positive. It's 1 negative. 1 is odd, so the answer is negative. And I'm just using the cycle method again to change this mixed number into an improper fraction. So 3 times 4 first equals 12. Plus the numerator 1 makes that 13/4. And again, I'm not worried about the negative. I'll remember to put the answer with it because I forgot to on that last one. And here I can see a cross simplification with the 4s. So those cross simplify as a phantom 1. This would end up being 13 over 1. But anything divided by 1 is itself. So I'm just going to make that -13 and call it good. Of course, I'm going to go to the calculator now, type it in exactly like I saw it, make sure it comes out as -13. Bam, I get that -13, and that completes this. The calculator shows me that my work was correct. And again, I use cross simplification on this. You could have just used the calculator. But also the prime factorization and maybe scale factors even would work on this problem. All right, what are we going to do about this problem, though? Because I got divide now by this integer value, which is okay. We should still be able to do that. We need to change this into multiplication. But before we do that, let's make the determination if the answer is positive or negative. Well, there's only one negative, which means the answer is negative. All right, that's good. Now I can ignore the negatives. Let's change the 4 1/5 into an improper fraction. So cycle method would show 4 times the denominator, 5 is 20, plus that numerator, 1 is 21. So I have 21/5, and it would have been divided by that 3. But I don't want to divide. I want to change this into multiplication. which means I need to reciprocate the 3. I'll show it as 3 over 1 and reciprocate it into 1/3. So now I've got 21/5 times 1/3. And yeah, 21 could be shown as 7 times 3. So I could, if I wanted to, cross simplify the 3's. Well, I guess I kind of mixed it with this prime factorization stuff. That's okay, either way. So multiplying the numerators, 7 times 1 is 7. And then 5, it'd be 5 times 1. It's just 5. Now that's an improper fraction, but we want the answer as a mixed number. So we'll take, what the heck, long division. 7 divided by 5. 5 goes into 7 once. 1 times 5 is 5. Subtract. So the remainder is 2, right? So that would be 1 with the remainder of 2. And the size is the fifths. So again, I'll go back to what I started with that negative. It's negative 1 and 2/5. And that would be the answer for this one. But again, I'm going to go to the calculator and check this. And what I have on the calculator confirms that my answer for this one and the work I did for it is correct. So again, we'll do the same thing on this one. Though I guess one of the big differences on this one is that there's 2 negatives being multiplied together. So that means I know that my answer is positive, and I don't need to worry about those negatives anymore. The 2/3 is fine as is. So I don't need to change that into an improper fraction. It just is a fraction, a proper fraction. But the 4 3/5, yeah, I'll use cycle method to change that. I got 4 times 5, which is 20. And then add that 3 right there to make this 23/5. Now again, I don't worry about the negatives because I know my answer is positive. And then I would look for any cross simplification that can occur, but I don't see any. So we'll multiply these directly. 23 times 2 is 46, and 5 times 3 is 15. So again, I'm just showing this with long division to show that, because I don't know if everyone has a calculator, but if you do, it makes this very easy. And long division shows 15 goes into 46 3 times. 3 times 15 is 45. So we have a remainder of 1. So this ends up being 3 with a remainder of 1. And again, this 1 out of 15. So that would be the answer right there. But again, I'm going to go back to the calculator and just check. All right, if elephant grass grows 3.5 inches a day, how many inches will it grow in 6 days? And no, I don't know if that's correct, scientifically speaking. And I suppose we don't care. We're just answering this question. Now, it grows 3.5 inches a day. How many inches will it grow in 6 days? That's like saying that we had 6 groups of 3.5, right? So we can just put this directly into the calculator. So 6 times 3 and 1/2. So I'm using the mixed number function on the calculator to do this. I'm typing it in. I got 21. That seems like it would make sense. 3.5 added to itself 6 times should be about 21. And we need to label it. Well, it's not 21, it's 21. And we do need to be careful on problems like this one. Sometimes students will label this as days. But again, it's how many inches will it grow. And this shows 21 inches. So we've seen one like this. I guess we're just with straight fractions. But if you only have a 1/8 measuring cup and the recipe calls for 6 3/8 cups of flour, how many 1/8 cups would you need to use? So how many 1/8 cups are in 6 3/8? That's a division problem. All right, so I know I'm dividing. And I'm going to take, again, it's how many 1/8 are in 6 3/8. So again, I'm just going straight to the calculator because this is a nice word problem. So, and this is this is the operation I'm using. So 6 3/8, right? So the mixed number function, 6 3/8, but we're dividing it by 1/8 equals 51. Now remember, the answer itself is not 51. We need to label it because it's a word problem. It's 51. I'm just going to say scoops. And again, that's because if I wrote 51/8 cups, it would look like a mixed number, 51 1/8 cups. But it's just 51 scoops of the 8th cups. All right, this problem, find the area of the rectangle. Well, we know that the area of a rectangle is found by taking the length and multiplying it by the width. And in this case, I can see the length right there, 6 7/8. So I'm just replacing that in the formula with 6 7/8. And the width, again, generally it's just a smaller number. So in this case, I'll say it's 3 7/8. And again, I know it's multiplication because it's area, length times width. So I'm just going to plug this directly into the calculator. 6 7/8. 6 7/8 multiplied by 3 and 7/8. Okay. And it should simplify it for me. Now the calculator spit out this value, right? The 1705 over 64. But I don't want the improper fraction because, well, the sections for mixed numbers. But we started with mixed numbers as well, so we'll express the answer as a mixed number. So I'm just going to change this into a mixed number with the calculator. Second, 10 to the power of n button, enter, and it gives me 26 41/64. But just, again, that's not the answer. We need to label it because this problem had labels in feet. So it's 26 41/64. It's not even feet, you guys. It's square feet. So we need to show that it's feet to the power of 2. That 2 exponent shows that it's two-dimensional, which area is. Right? This whole thing gave us a certain amount of area, which is in what we call squares, right? These are square feet. So before we look at the next couple sections, and we'll go over those, but I want to point out when you're looking at operating with mixed numbers, and we've only gone over multiplication and division. Some of you guys have thought, well, what about those common denominators? When we multiply and divide fractions or mixed numbers, we don't need common denominators. We will for addition and subtraction, but that's coming in a later section, okay? So we don't need to worry about common denominators yet, but like you have thought, it is coming, okay?